we are going to talk about the Krypton system. And first, you are having a camera. The camera has 3 different lenses, and the 2 outer lenses for Y and Z axis calculation, and the middle one is controlling the X axis. And also there are sensors involved, and I think we can pass one around. So those are the LED sensors that captured by the camera, and this will go to a port, and the port will connect it to a controller called the Krypton controller, and you will have that in your handout as well. It is here. Probably the video cannot capture it. And also you are going to have a software computer connected to the controller. So the camera, sensor, and the controller and computer, that forms the basic acquisition system of the Krypton system. And in addition of that, we are having a probe. The probe is for setting up a reference system that we are having it. So this is the probe that we are talking about. So each probe, we are having 3 sensors at the corner. So including its 9 sensors, and that will be captured by the Krypton cameras. So we are going to measure the position of the probe. And the resolution of the measurement is about 8/10,000 inches, which is equivalent to 0.02 millimeter. So that's a very high accuracy system. And we need to do calibration for the probe so we can have an accurate reference system. So doing the calibration, we need some reference target. So this one is the calibration, part of the calibration procedure. This is the K reference R. So based on that, we know the length of the K reference R. So that is going to give us understanding of the measurement and also the given target. So today, what we are going to include here is the step-by-step procedure about how to start the system, calibrate the probe, and calibrate the reference system, and then go to measurement. So if time allows, at the end, I think 3 of you can form a group and try to run the test or run the acquisition on the computer side. So I think Francisco will continue after me to show the steps, and I will be here for.
So basically, as Gaby already told you, this is the Krypton system, this is the controller, this is the camera. It's very easy. You just set the tripod and then put this inside. We have some boxes. These boxes over here are for the Krypton and for the bar. This is very easy. You only need to plug in this cable over here. So you have to follow the red dot. And that's it. These buttons in the back doesn't have any function, so don't worry for them. Here we will connect the camera to the controller. This should go here, camera. So it's very easy. And you only have to follow this red dot. The idea is that you have to connect the camera and the space probe. For the space probe, we have
And by the way, we are on I think on page 4, and you can follow that. It is hardware and software setup.
So basically, the space probe has these 3 yellow circles are the sensors. It has 3 sensors in each circle for a total of 9. The camera should look at this in order to take the measurement for the initial setup. this is a system that is around, it was acquired around 2007, 2008. So right now we are using this computer that has Windows XP. For using it, we need to update it. But Bowen Lab has two Krypton systems in case that you need it. This is a little older than the other one. The other one is like 2 years younger and newer. But at the moment when we start to set up everything, it was at night, so the other system is locked. For that reason, we are using this one. So you connect this in the Space Probe port. And some of the tricks here is that we need to turn on the controller first and then the computer.
Yes, and this is also stated in the manual.
So can we ask questions now, or if you have questions you can ask? So what do you mean the system is locked? What?
No. The other one is in a locked room.
Oh.
And we couldn't access to that room because it was during the night. So Kevin wasn't here.
I have a question.
Yeah.
So what you mentioned before, what were the difficulties that you had when you started the computer first and not the controller?
Yeah.
Sometimes it doesn't detect the camera, it doesn't detect the controller.
If you see I think it's at page 5. I think, it's still page 4. If you see the last figure, there's supposed to be a K-link that you are going to see 2 green dots, green bar, and one of them is picking up the controller, one of them is picking up the camera. So it means the camera and the controller should be started before it can be detected. So it is easier when it's already started and then you start the software. Otherwise, it may not detect the hardware. So it's just in case. So we learned it from experience that it's easier to turn on the controller and be detected by the software later.
Okay. We have the same issue in UAC.
Yeah. And not really mentioned in the official manual because it shouldn't be a problem, but when you really do the real test, and sometimes you find, okay, this might be a good procedure to stick with.
I'm trying to make the icons bigger. Okay, so basically the software that we are going to use is this DMM.
The DMM is the software that takes care of all that acquisition. And inside DMM, you can set up your system, and it will trigger other software to pop up. It will pop up during the process.
Okay, so basically we are going to create a new project. Gaby, can you do that?
Thank you.
So we have the project, and then we are going to start by identifying our system. So we need to go to identify tab, then start. Now he's reading the space probe.
So when you do the identify, it will start to trigger the requirement for the space probe, and it will start an interface called geolog. In the geolog, you can calibrate your space probe, and also you can set up your reference coordinates. That is the XYZ direction that you want to set for later for the sensors.
So right now the system is asking you if you want to use the whole setup for the space probe and for everything, or you want to recalibrate. So we are going to start from 0, so we are going to recalibrate in this time. Next time you can just reuse it. So the thing is that we are going to start the calibration process, so we need to do 2 types of calibration. One is for the space probe and one is for the distance. So initially a good separation between the camera and your target should be around 3 meters. So you can take that into account. This bar has a fixed length. In this case, it's over here. 1515.95 millimeters, so almost a meter and a half. But it has that specific length, and we need to, for the calibration, as I told you, we are going to go this. First, we are going to calibrate the space probe over here. So he will ask you, the camera automatically detects this as the Z direction. So he's telling you that he needs to reach some angles in the Z direction. So what we are going to do is, we need to put the space probe here, and we need to take measurements covering this some angle over here. Those 9 green dots that you are seeing there are the 9 sensors. All of these 9. So if I block 3 of them, you cannot see those.
And also this is going to turn red as well.
Yeah, so this indicator, this LED will indicate if it's green or not. Green is okay, red is bad. So we have 5 buttons in the space probe, 4 inside, 1 outside. The 4 that are inside are to taking measurements. The one that is outside is to confirm that you are done with the measurements. So we are going to start from,
And
We can
it
start from
is
here.
suggested back and forth, left and right, each direction take 5 points. And that is at least, that's suggested, but you can also.
so basically the bars over there is like what is happening in this direction, and then in this direction, and then the last one is that you have to keep the space probe in one point. You shouldn't move it a lot of.
We find that's the most difficult one.
Yeah, that's the most difficult. So you
need
have to
be
be
very careful.
very good.
And some of us, we have magic hands, and when we do that, when some of us doing that, the arrow goes down very easily, and when some else doing that, and always one criterion cannot be satisfied.
So look, we have 1 point. Look there, because I'm not taking the one in the right hand side is 3.62 millimeters. That's so big, so you have to be very careful. We want to go it again. Now in this direction. I think that
Do you see
yes,
that?
Yeah, I'm looking
So-
there. So it's,
I'm going
you have to be very careful and you have to do it many times.
I think I'm going to invite one of the volunteers to come here and try
Sure.
to see if they
Why not?
can satisfy the.
So look here, I'm almost done with the procedure, but I'm not, I don't know, satisfying my last point. I haven't moved a lot of this over this area. So we want to cancel it.
So,
Do
and
it
if
again.
you,
So how many points do you need to capture?
You need to just put those bars in the green area.
so back,
Basically,
forth,
you need to cover some
yeah,
angles.
back, forth, left, right, each direction 5 points at least, and then it's suggested. And this is a trade-off between how many points you want, and make sure you don't move your probe. And
For that reason, you don't want to
Have more,
recalibrate
yeah.
every time. You just want to reuse it. You want to calibrate the first time and that's it.
What is the number? 0.06, right?
0.06.
Yeah, no.
And the
Gaby, can you?
suggested number is 0.06 millimeter for the last part. Because it's easy, because the range for the left and right, back and forth, they are broad. And at the last, the criterion should be the error bar on the position. So that requires you to move the probe.
So that means the
camera
probe is
is
moving
looking
downward
here, right?
by that much?
That
Yeah.
means the probe is moved.
That one is the discrete.
In that
You are
sense.
recording with
The
that?
tip is
The
moving?
tip is moving. The tip is moving. Doesn't matter which direction.
In the depression.
Yes. And you probably we can ask some of the students to come
Yeah, sure.
try. You didn't capture.
Yeah.
Can you
Oh.
control the
You didn't.
ones?
Gaby, can you just click? We are going to edit the video. We need only one.
Okay. Here we go. Yeah, it's better. And that's the best try for
Yeah,
us.
do you want to try again?
I think Weston.
Stop.
Do you want to try?
Okay, come on.
Come on, come on.
I have tried that back in IISL, so maybe you can give the opportunity to someone else.
Okay.
But I have a question. So that indicator, the right number of 0.1 millimeter, something like that.
Yes.
That will give you the accuracy to detect lines, points, etc., to create your reference system using that Swiss code. Like, so if I got a bad number there, basically what I'm going to have is that bad or bad accurate value for my system reference, not for the information that I get from my entities.
Yes, that's separate. The probe and the LED are not the same. Yeah, are not in the same calibration.
Okay.
But that will affect how you define. Good.
We did it.
We'll keep it.
Yeah.
Still,
So.
we can ask anybody else who wants to try work.
Yeah, sure.
Probably we can.
Who wants to try?
Did I click anything?
No.
I heard a sound. Leaders? I saw you.
You can say that.
Yeah, let's save it first
Let's
and
save it.
then.
Yeah. There's a high probability that I won't be able to make your
My phone is
impressive calibration skills.
You don't need to use the rope for this calibration. It has this kind of box
Magnetic.
that is- yeah, this is a magnetic
Yeah.
connector. Let
So-
me see. So if you,
Does that hold the typically?
yeah, you can put the tip over here.
So then that will
Because
make
it
a
has
round.
this hole over here, so you can see.
You can pass this around a little.
No, so what is this sticks to metal?
Yeah,
surface?
you can just turn it on.
Metal surface, yes.
I think, but this is not.
They should have made the tips like
Yeah.
that.
There are different tips. You had a very good question. We have different tips, and this is recommended for use the 10 millimeter tips for the calibration. And also here are some other tips, which is smaller. They're smaller. And also there are different extension rods to make your tips further from the probe itself, so it may be captured easily by the system. But also for calibration, we do not include
So
the extension
I'm not
rod.
completely clear about the purpose of this calibration.
The calibration, you will see it later when you set up reference system. This is going to scan a reference system.
Yes.
So all the sensor is based on the reference system you set up. And the reference system accuracy is based on the accuracy calibrated from this road.
So basically, this calibration is telling the system that this point is at this location. It doesn't matter how do you put the probe. You can put the probe in one direction, in the other,
so it's
that he's
calculating
able
the
to
location
capture,
from these lines.
this location, and keeping that value between a very small bracket.
And here is where you go to calibration under the front banner.
Is there any reason that you conduct the calibration of the space probe using the reference bar other than using the magnetic base?
Because we want to show you the whole process for calibration.
Okay.
But you can only use that magnetic. But also if you want to do the calibration of the rod, so we will show you for that reason we have this over here. But you can only use that one and use.
I have a question.
Yes.
So, is there any reference distance between the Krypton camera and space probe? Like, it doesn't matter how,
Maximum.
like, distance between the camera and the space probe, or the height of the K-reference bar. So we can locate anywhere.
No, there is
it should be
range.
like the ideal separation is around 3 meters, 4 meters. It can capture maybe something around 10 meters, but after that it's so far that maybe your measurements are not.
So they have the wide range, so we can just.
Here is the thing. There is the trade-off between the size of the structure and the distance, and also there is a trade-off between the distance and the accuracy. So.
You're okay.
0.08 is
Yeah, that's perfect.
So then what I.
0.08. No, the tolerance is 0.06.
Yeah.
But this is good for
the demo it's okay.
And the thing is, what I experienced when the last error bar goes up, it's very hard to make it go down.
Probably you just need a lot of measurements.
Yes.
Because it's doing like a least square measurement. Probably it's not going to go. Maybe it might.
Save. And then so we have done the calibration for the space probe. Now we need to do for the K-reference bar.
So do you find ever that this does not turn green easily? If it's too far?
If it's, I think, no, I think 50, you will see it.
Okay.
Yeah, you don't have any problem. Maybe if it's too far, more than 10 meters,
Yeah,
you
so
will start having trouble.
I think that's on the thing that the space probe we have. Sometimes it doesn't turn green easily. So I guess you have to get it checked.
Okay, yeah, maybe.
So we
now
finish
we
the.
are going to do the K reference. You have to, you can look here. This is the measurement that we are going to take. So Krypton camera should be over there, and the system, the K reference bar, should be here. One of the things is that we will rotate this bar in order to take some measurements. We want to take this length in different positions. So you won't always want to keep the tripod at this side, like on the left side of the camera, and the rod on the other side. Because right now, for example, he's asking for set the bar, the length of the bar. So the Z direction is right now is this direction that we have over here. Okay. So
How do you ensure this? Do you have to ensure?
It has some kind of
reference
guidance over here. It doesn't have to be precise, very precise, but you only have to follow, like, have some similar than these guidelines. So, we're going to
What's the purpose of that?
measuring this length in different positions, different rotations. When you rotate this bar, and you want to make sure that always the distance between those 2 points are the same. So we are going to start here. So we have 1 point, the second one.
Yes.
So this process is also to calibrate the space probe?
No, the space probe is already calibrated. We want to calibrate that those measurements. So basically, we are with the space probe. We are telling, okay, this point is at this.
Probably should we do it again?
Yeah. So yeah, in this particular case, when I was taking the second dot, I saw that these LEDs become red. So yeah, didn't took a good measure.
So it should be less than 0.1 millimeter. The error.
0.1 millimeter. Almost.
I'm not sure if it's point
Yes.
point zero.
0.1.
That's close.
I think we are too close because I'm not able to take the measure here. So it's difficult to get the green light. Maybe we want to repeat it.
From the beginning to
Yeah, okay. So yeah, the thing is that when I was taking this measurement, I kind of get the green line easily. So maybe we are too close to the system, to the camera. But we edit that.
and it's not entirely safe. This end is high. This end is higher. And Gaby, could you tell me when is horizontal? Does it
Oh.
look horizontally?
No, it's already
No, I mean this bar.
There.
The bar.
Now?
Is it how horizontal? We are too close. Let me know if the bar is horizontal.
Oh, horizontal?
Yeah, see if it's horizontal.
Yeah, it looks like it.
No? No, it's anyway.
No?
No, it's not.
It's not. It's still higher.
There. No.
Yeah. Let's
There.
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 Yeah.
So the direction of the bar is going to be the z direction.
Yes, that's the first one.
Good.
Click next.
So this is not to check your accuracy, it's just to check your calibration.
So there is the reason that we need to calibrate space probe and then K reference, because space probe first is trying to get rid of the influence of the inaccurate probe detection, and then K reference is trying to get rid of the temperature. So that's why you need to do that procedure.
Thank you. Thank you.
Yeah. So see, all the point turns green. It means we satisfy the KREF2 criterion. So if we click, let's click OK, we directly apply the compensation. And then it will lead us back to the geolog, and then we can start to determine a coordinate reference, and that will lead to the measurement. And so on the menu, we should go to page 9, and that will give us the steps to set up reference coordinate for measurement.
So we are done with the calibration. Now we need to start defining the reference plane and then take some measurements. So in DMM, I don't want to do that. Take some measures, start. We want to start with a plane, then a line, and then a dot. In that specific order.
We should still close so we can, because the clip.
That's it. Do you want to take the measurements, or I should? So you need to go to this tab, measure, and then pick plane. So we are define a surface, and we are going to take some measurements. So you remember that you have to take the measurements with the buttons that are inside the probe, and you will confirm with the one that is outside.
I think, sorry, I created it. I need to do it this direction, so careful.
So basically what you're doing now is define a plane that is parallel to the surface of the table, using those points with the aid of the magnetic things, right?
So basically we are defining a plane, a line, and a dot, and we will use those to define our system. What is our origin, what is x, what is y, what is z.
In practice, when you have used Krypton to conduct a structural test outside or inside your lab, you have defined planes using information from your specimen or some other reference from your lab?
So for example, we have done a test on the shake table. So we use the shake table as the plane. If we have a shear building like 3 stories, 4 or 5 stories, we typically use one sensor per floor, and we put those sensors in a vertical line. So you can use that one as the line, or you can use only the bolts on the shake table. So that's what we typically do.
And I also know people doing the large scale test, for example, one concrete column, they are using the corner of the column and the point, like the foot tip, and also the line of the column to edge as Y and Z, and then the face or the line that's on the other edge to be delivered.
Now we have to take in
Yeah, I have
in the entire frame. Okay, so
cover.
outside to confirm.
And
So you have to repeat.
because we moved the table anyway.
Yeah.
So let's delete it and start
Yeah.
again.
It wasn't you.
It was me. I'm trying to pretend that it's not me. Is working correct?
Yeah.
Do you want to?
Yeah, we need to make it.
Anybody?
Okay.
Yeah,
You
got
have
it.
one done.
But the origin is going to be somewhere.
Because you don't have error. What is it?
Thank you.
You can, yeah, the idea is that you will use those for the defining your system. So we have this, the plane, the line and the point. We want to go to operate, the operate tab, and we want to create a coordinate system using those features. So this will be the frame, and we will say, okay, what is the primary axis? It will be X, it will be in the positive direction of the line, and then we will use Z, that should be on the plane, and we will use the origin as a point.
And orange X, Y, Z, I think both of them should be point forward.
What?
There's orange X, Y, and Z. So both of them, all of them should be
All of them
point.
should be point. Yeah, I think so.
So, if you wanted to, you could also set your origin as one of your sensors and say,
No, not yet.
But you need to take you need to do this. Take the probe and put it on the sensor.
oh,
Yeah.
you can't misuse the sensor.
No, it's not really capturing the sensor yet.
But later can you do that?
I don't think so.
We haven't done that. Typically, you just use the signal from one of the sensors and then you subtract that signal
Yeah.
from the other, and you will do it like manually.
Okay.
So you mean like doing some sort of relative measurements?
So you're measuring the sensors. It's like this standard coordinate, and then transforming it to those coordinates. Instead of transforming to those coordinates, since you can specify any point, I was wondering if you could also specify the point.
Oh, I see.
They are-
So okay, you have your coordinate system. You have it over here, and what you want to do is drag it over here, and then confirm. So it will send. We are using geolog right now, and we create all of this, the frame, the coordinate system, and we are sending that system to the DMM.
And that step, I think I missed it on page 10. So make sure your market send the confirm, like the blue arrow. And I will add it to the new version, but for this version, I missed that step.
Okay, so now we want to start taking measurements. So we have the sensors already here. We have 5. We need to connect the sensors to this box. Each one of the box has a capability of 20 channels.
A question about the sensors.
Yes.
Do you have different kinds of sensors?
What?
Different kinds of sensors, or is there only one kind of sensor?
I'm not sure in the other systems.
There is a bigger one.
Yeah, the big
the orange one.
Yeah.
But in this Krypton system, we haven't used the bigger one. So, of course, it should be compatible. And I don't know the difference between the bigger one and this
Yeah,
one.
because I've seen we have the bigger one.
What are the bigger ones?
Sensor. Really?
Oh, yeah, you're right.
Do we also have the small one?
I don't know. I thought that, but those of the other day mentioned that there are other LEDs that are wired. These are very expensive.
No, these are still wired.
No, these are
But
wired. We
the-
also have wired. I thought that you were mentioning the wired.
the difference between the ones we have.
Yeah, but I think that I saw those in the other
Yes,
system.
that's-
Yeah, the other one has the big one.
And I'm not sure if it's just cover that make it bigger. I haven't checked in detail.
Maybe.
Yeah, I think.
Yeah, no, but we have this system and the bigger ones work.
Okay. Okay, in this case for the sensors, we have these two ports, the 3 and the 4. So you want to connect the box to those ports. Okay. So we already identified.
How many strobers can you connect to the controller?
You mean sensors or the box?
The
The box with strober?
There are
I think we have 4.
4 ports, and the first 2 and the second 2, they are not different size, and this is probably using the smaller box that have different connection. And each of them is 20 sensors, so probably 40 will be a good number.
What other question I had in practice or your experience, how many sensors can you connect to one controller or one camera? Maximum number of sensors?
40 should not be a problem.
But the
problem
problem is the
sampling frequency.
sampling frequency.
Yeah.
So if you put more sensors, your sampling frequency will be lower.
What is the
Relationship?
minimum or maximum sampling frequency you can get for the highest?
We can check.
There is the description in the menu. 3 is 1000 hertz, and 5 is 674, and 12 is 289. That's, I think those are the numbers that we recorded last time.
Yeah. So we can check right now when we are trying to take the measurement. So we go to acquisition, measure. Here we have to put in a name for the file. Typically, this system will give you 2 types of files: CSV, comma separated values, or MATLAB file. In this case, it's already for MATLAB. You only need to put the name. How do you start your system, the triggering? So by clicking a button, and then we want to take measurements for a specific time, or you can just use keyboard to like stop it manually. But in this case, measuring time, settings, you define 1 minute of recording. And here you can use the frequency. You can define the frequency, but you have to go to K camera, set the number of sensors, and we are connected on port 3. We have 5 sensors. If you go here, the system is telling you that with 5 sensors, the maximum frequency is 674. So let's change it. What happened with 1? 1000 hertz. With 20 sensors, 175 hertz.
So one comment about that, in Illinois we have used Krypton to make coordinate measurements of structural specimens like reinforced concrete walls, things like that. We have used dense LED layout, and we have used up to 130 LEDs for one camera, right? But what happens is if you add more LED, well, and it's okay to use that because we were conducting hybrid test, slow speed, so we didn't have any problem with the sampling rate. But the problem was if you wanted to add more LEDs than that, software has a problem and crash. Right? So in theory, if you go to the manuals of Krypton, they say that you can have around 300 LEDs connected to that, but that's not the practical, right? And we contacted metrics by that time, and they said that the software has some issue, but it's not a problem of hardware.
Also, I think also was saying that when you have more than 100, because they're all in series, creates a power problem for the few at the end.
Yep.
And so the intensity of the infrared that they're emitting is not enough to be properly easily identified.
In theory, you can connect one scroll box to another in series. So you can have more than 40 LEDs,
Yeah.
right?
Yes, that's what I remember.
But the last box on that line of scrollers probably will get less power than the first. You cannot light those LEDs.
I think we haven't used it so many, right?
Yeah.
We typically use some, I don't know, scale structure in the lab, and we have to use maybe 10, 20.
But that's very good knowledge to pass
that's
between us. Yeah. So if we ever going to do a large specimen test, we need to be aware of that and the maximum that we can afford.
Yeah. So the motivation to use dense LEDs was that you imagine that you have a wall and you have LEDs in a face of that wall, and you can measure displacement of each LEDs, and with that you can construct a strain map, a stress map for the whole test. But the only problem in doing that is that if you have damage in your specimen,
They do a photo.
yeah, you will lose information because those LEDs will be removed from the specimen.
And how large was the data? Like you have 130 sensors, and you have how long the test? Like 2-3 hours?
As long as it's needed. So basically they have another computer that holds all the data and creates a repository.
So the computer, the software will not crash if you take like a very long time data. That will be fine, but just the number of sensors will affect the...
Correct, but you need to connect your controller or your computer with Krypton to another host that will get the data, because it's not probably your computer with Krypton to crash.
Because I store it in RAM and then
Oh, very interesting. Okay, so let's continue.
Okay, so we have the 5 sensors. You can change names here, and you can apply some factors, some offsets. So you want to go to K camera and start K check. So right now we are going to start to tell the system that we are going to start taking measures. So he's looking for this software. One of the problems that we have seen is that it's not opening the software automatically, so you have to go and look for it, and open it. So it will be waiting until you open the software. Okay, yeah, it's over here. Now he can detect the controller. We have the probe, the 4 ports, and the camera.
And also you probably want to mark that on the menu. I missed that step too.
Okay. You need to open the K-link
Yeah, I
by
want to,
yourself.
yeah.
You want to go to the settings, define that you have this 5 ports, 5 channels in that port. You can also use the ones on the Space Probe. If you want to take measurement with the Space Probe, you will have 9 channels for the 9 sensors over there. Everything is okay. The frequency. So you can initialize your system. So now it detects that you have the 5 channels. You can start. So basically the system is ready for taking measurements. So you go to DMM. Where?
K-view.
Here. You want, okay, K-view. So now the system is taking it's recording everything, and you can do a final check, opening, it's not here.
Desktop.
Yeah, shortcut, no. So we want to use,
K-view.
what you see him? I
Or
don't see it.
before VLC, like down, up, this one.
Okay, this one. Okay, that is the shortcut. So you want to open K-view, so you can have an idea of what is the distribution of the sensors and if they are making sense. So we have the camera over here, and here is what you can, you have to the tool. I will rotate that.
So this one is a little bit out of plane, and not this one formal as not
So this is the,
What's the reference system here? The one that you define with plain points and line.
but this is what the camera is. I don't know, this is like the reference system for the camera.
Yeah. What about the other reference?
I think that's only in geolog, no?
Yeah, it's in the other side, but it's not in this because this is K-view. This is only telling you what is the camera viewing and if it can detect the sensors.
So the one of the LEDs set up at the back. So when it vibrates, that LED is blocked by the other object.
Yeah, at some points it can be blocked and you won't get any data
So
for
it
that
should be
specific
visible,
time.
like from the
It should be
camera.
visible. But if you see it directly from the front,
So that means
actually it's not problem. It should be problem.
But it
But we have
means
three
we cannot directly set up the camera. It's just like we have to little bit tilt. We have to make it locate the camera a little bit tilt.
So the thing is that since the camera has 3 lenses and the separation is not that far or not that close, it's like an ideal around 3 or 4 meters, you are able to see all the sensors in this case using the 3 lenses. But for some specific configuration you can be doing that error, blocking the view.
So which means we have many like a more layer in this direction that would be equal to measure. So
Yes.
look.
Yeah, it will be more.
And the only reason we added the last one is to show the derivation from the first plane and the second plane. And I think Gaston's case, like we put all the sensor on the same plane, and that will not have the blocking problem. But during measurement, there is always having chance, like you lose sensor and the sensor drop, something like that. So we want to avoid those, but some of them may just happen when the time comes.
But one good thing about Krypton is that if you get the data output as a MATLAB file, for each sensor you will get one variable that will be 4 rows and number of columns, which are the samples you get. The 3 first rows are coordinates X, Y, and Z, and the 4th row is a quality vector. So it will give you information whether
The manual to see if
There
there
are probably
is something
not-
because I don't know the answer. So everything looks okay. So we have the data, we have the sensors. So you just need to go OK, and it will open automatically this acquisition system. Okay, so this will be the name. This is the frequency, and you just need to. Okay. We need to start the shake thing. But it's moving, so we will have that slow. So here, it's telling you that if looking all the sensors that you don't have any problem when it becomes red, is that somehow some of the sensors are locked and the camera is not able to see those. You have your computer. Do you see the data? It's weird. We can repeat it.
It's on the desk.
Can we start again?
Yeah, we can take another. So the thing is that as soon as the test is over, it will closes the acquisition. So you have, if you want to take another one, you need to do it again. Acquisition measure.
And
You have
also,
set up everything.
one
Okay.
second. There is the panel that allows you to input commands, and you can input commands with export function, so that will export to the CSV format if you desire. And now it's automatically saved in the file. Let's try Northbridge this time.
Okay, it's recording.
Let's start.
Yeah.
that red line flashed out, and that means for some reason it missed the measurement. Don't know why.
I have a question. So
Yes.
for that particular test, or only measurement of impact will be the X direct, right?
Do we have a flash
But
drive?
it will give you the direct info.
Yeah, I will give you that.
It's on a hard drive. No?
And you can see some
Yeah.
small variation
Yeah.
in the Y and the Z.
You can find.
So I think the files are here, DMM, projects, okay, training. For some reason, you just label those files, put that name, that long name, acquisition, position 3D. What is this? This test 1 and test 2.
Not open.
No, by mistake I just click open. I was trying to see. For some reason we don't have MATLAB in this computer.
Now for pretty obvious reasons.